In this video, we're going to be looking at the guided practice problems for counting atoms. You should have already attempted these problems. This will just give you some extra help if you are struggling with these. So let's take a look at the problem, the first problem. In this problem, we're being asked how many sulfur ions are found in 3.55 grams of iron 3 sulfide. So with that problem, we have a mass, and we're being asked to find ions. So the first step is we know that we've got a compound, iron 3 sulfide. We're going to need to figure out the formula. The name of the formula, the iron 3, tells us that the iron has a +3 charge, and the sulfur, has a -2. So we know that that formula is going to be Fe2S3 to give us a neutral compound. Now, let's talk about these types of compounds. Remember that ionic compounds are not called molecules. We call them formula units because of the fact that they are those repeating patterns of ions. They're not those separate little molecules. So we know we're going to have to find ions, and in order to find ions, we know that we're going to have to find our formula units. So if we have one formula unit of Fe2S3, then we know that it will have 3 ions of sulfur. And so we know that at some point we are going to have to use this as a conversion factor. The problem is asking us to find how many sulfur ions, so it is very likely that it will be at the end of the problem. So let's start here with our mass of iron 3 sulfide, and then we can figure out what we need to do. So if we have our mass of iron 3 sulfide, we know that we're going to need to get to molecules, and in order to do that, our first step is to convert to moles. So we're going to set up our factor. We want to go from grams to moles. And in order to do that, we're going to need our molar mass. You should add up the molar masses of 2 irons and 3 sulfurs. I hope you've already done that. And that gives us a molar mass of 207.91 grams. That's a decimal there. Let me erase that, fix it. And that's 207.91 grams. And that's the number of grams. Our molar mass is the number of grams in 1 mole of a substance. So 207.91 grams of iron 3 sulfide in 1 mole. Now we need to go from moles to molecules of iron 3, formula units, of iron 3 sulfide before we can calculate our ions. So we want to set up our equation, our conversion factor, so that we have moles on the bottom, and we have our particles on the top, which are formula units of Fe2S3, and we know that our particles, we use Avogadro's number to go between particles and moles, so that's 6.022 times 10 to the 23rd. Our particles here are formula units, and that's the number of formula units in 1 mole. So our particles, we use Avogadro's number with our particles. And now we're going to be able to use our conversion factor here. We have 1 formula unit of iron 3 sulfide, and that gives us 3 ions of sulfur. So we want formula units here on the bottom so that it will cancel out. And then we want our ions of sulfur on the top, and that will give us our unit that we want in our answer. And in 1 formula unit of Fe2S3, there are 3 ions of sulfur. When you go ahead and punch that into your calculator, you should end up with 3.08 times 10 to the 22nd ions of sulfur. Let's look at another problem. In this problem, we're being asked what volume in milliliters of 0.34 molar sucrose solution contains 1.5 times 10 to the 23rd carbon atoms. It's giving us the carbon atoms, and it's asking us for the volume. Now we know that in 1 molecule of sucrose, which is C12H22O11, that it contains 12 atoms of carbon. And so we know that we'll need to use this as a conversion factor to go from atoms of carbon to molecules of sucrose. So let's set that up. We've got 1.50 times 10 to the 23rd atoms of carbon. And we want to go from atoms of carbon to molecules of C12H22O11. And in 1 molecule of sucrose, we have 12 atoms of carbon. Now that we've got our atoms canceled, we have molecules, and we already know how to go from molecules, not straight to volume, but to moles first. So we want to go from molecules to moles, so we need molecules on the bottom to cancel. And we want to go to moles of sucrose. And we know that in 1 mole of anything, there are Avogadro's number of particles. So 6.022 times 10 to the 23rd, that's a 23, bad looking 23, but it's a 23, molecules of sucrose. Now that we have our moles, we know how to use our molarity as a conversion factor to get to our volume. We've got moles on the bottom here. And we want to go to our liters. And so we know that our molarity, remember our molarity equals moles over liters. So that's 0.34 moles in 1 liter. Now our problem is asking us for our volume in milliliters. You can do that in your head, or we can just tack on another conversion factor here to go from liters of C12H22O11 to milliliters. And remember that we use, sorry about that, we use our scientific notation with our base unit. Our scientific notation with milli is 1 times 10 to the negative 3. So if you do that, you should get 61 milliliters. Remember, there are only 2 significant figures in your concentration, so that's why you end up with 2 sig figs.